Hi, welcome to 2.4, the chain rule. The chain rule. Let y equals f of u. It's a function of some variable u. It's a differentiable function, and u of u, and u equals g of x, where that's also a differentiable function. What we have is a composite function here. Where f of x is the outside function, g of x is the inside function. The derivative with respect to x is going to be dy du times du dx, or it might be easier to see this, derivative with respect to x of f of g of x is f prime of g of x times g prime of x. So it's the derivative of the outside function with the inside function staying intact, then multiply by the derivative of the inside function. So we're going to spend one example here, breaking them up to our inside function and outside function. So if we have y equals 1 over the square root of x plus 1, the inside function is going to be u equals x plus 1, whereas the outside function is going to be 1 over the square root of u. So doing 1 over the square root of something would be the outside function, where the inside is x plus 1. And the next one, the inside function, is x squared minus 1. And the outside function is going to be, I should say, u equals x squared minus 1. And the outside function, y equals the square root of u. Next, y equals cosine cubed of x. Think of this as cosine of x quantity cubed, so that our inside function is cosine of x, and our outside function is u cubed. So for example 2, it says find dy dx for y equals the square root of x squared minus 1. So our inside function on this is the thing inside the radical. That's x squared minus 1. We'll call that our u. Our outside function is just doing the square root of that u. So our y prime is going to be, I'll think of this also, y equals x squared minus 1 to the 1/2 power. That power would come out front. And when you multiply by the derivative of that inside function, what's the derivative of x squared minus 1? That's going to be 2x. See, the derivative of u to the 1/2, f prime of u, is 1/2 u to the negative 1/2. That's what happened here, where our u is the x squared minus 1. And our u prime is going to be the 2x. That's what happened there. So our y prime is going to be, well, look at this. We have 1/2 out front, 2 over there. So it's going to be x over the square root of x squared minus 1. Okay, I'm going to go on to the next concept, the general power rule. So the general power rule, y equals u of x to the n power, where u is a differentiable function of x and n is a rational number. Then dy dx is n times u of x to the n minus 1. So just like we do normally with derivatives, that power came out front, subtract 1 from the power. Then we multiply by the derivative of u with respect to x. Otherwise you could see d dx of u to the n is n u to the n minus 1 times u prime. So find the derivative of f of x equals 2x cubed plus 1. Well, our f prime of x is going to be what? This power comes out front, 2 times 2x cubed plus 1. Subtract 1 from the power, we get a 1 times the derivative of what's inside. What's our derivative of 2x cubed plus 1? It's 2 times 3x squared plus 0. So f prime of x is 2 times 2x cubed plus 1 times 6x squared. You multiply this all together. 2 times 2x cubed is 4x cubed times 6x squared is 24x to the 5th. 2 times 1 is 2 times 6x squared is plus 12x squared. I'm going to go on to the next page. Find the derivative of y equals 1 over the square root of x plus 2. I would probably start by rewriting this as y equals x plus 2 to the negative 1/2. So that y prime would be, this power comes out front, negative 1/2 times x plus 2, negative 1/2 minus 1 times, what's the derivative of the stuff inside? That's just 1. So y prime is negative 1/2 times x plus 2 to the negative 3/2. Y prime is negative 1 over x plus 2 to the 3/2, or negative 1 over the square root of x plus 2 cubed. Okay, I'm going to scroll this up because I want to get some more space for this problem. For example 5. Find all points in the graph of f of x equals the cube root of x squared plus 1 squared for which f prime of x equals 0, and those for which f prime of x does not exist. So what we have here is f of x equals x squared plus 1 to the 2/3 power. Our first derivative is going to be that power comes out front, 2/3 times x squared plus 1 to the 2/3 minus 1 times 2x, the derivative of what's inside. So our derivative is going to be what? 2 times 2x is 4x over 3. 2/3 minus 1 is negative 1/3, so we have x squared plus 1 to the 1/3. Or f prime of x could be seen as 4x over the cube root, well, 3 times the cube root of x squared plus 1. So the issue we have here is that we first want to find where the derivative is 0. F prime of x equals 0, where 4x equals 0, the numerator, which is where x is 0. F prime of x does not exist for the places that the denominator is 0. So x squared plus 1 is 0. X squared equals negative 1. X equals plus or minus I. Now that's imaginary, so it'll exist for all real numbers. Pause if you need to pause this. Differentiate. S of t equals 1 over t squared plus 3t minus 1. So this could be seen as t squared plus 3t minus 1 to what power? The negative 1 power. Very good. So S prime of t is going to be what? Power comes up front, negative 1 times t squared plus 3t minus 1 times the derivative of, to the negative 2 power. Negative 1 minus 1 is negative 2. Times the derivative of what's inside. The derivative of t squared is 2t, and the derivative of 3t is just 3. So s prime of t is negative 2t minus 3 over t squared plus 3t minus 1 quantity squared. Okay, now we're going to find the derivative of y equals x squared times the square root of 1 plus x squared. Use a product rule with the chain rule, it says. Think of this as y equals x squared times 1 plus x squared to the 1/2 power. So y prime is going to be the first thing, x squared times the derivative of the second thing, which is going to be 1/2 times 1 plus x squared to the negative 1/2. The 1/2 minus 1 is negative 1/2, times the derivative of what's inside, and that's going to be 2x, plus this second thing, which is 1 plus x squared to the 1/2, times the derivative of the first thing, which is 2x. So y prime is going to be x squared over the square root of 1 plus x squared plus 2x times the square root of 1 plus x squared. Okay, I'm going to go on to the next page. Find the derivative. Now we have a quotient rule issue, quotient rule, and we have a chain rule. So think of this as, we could call this x over x squared plus 1 to the 1/2 power. So recall what this is going to be. If y equals f over g, y prime is going to be low, so g times f prime minus f times g prime over g squared. So y equals x squared plus 1 to the 1/2 times 1, the derivative of x is 1, minus x times 1/2 times x squared plus 1 to the negative 1/2 times this derivative is 2x, all over x squared plus 1 to the 1/2 gets to be squared. Okay, and this 1/2 cancels with a 2. So y prime equals the square root of x squared plus 1 over 1 minus x times x is x squared over the square root of x squared plus 1 over x squared plus 1 to the 1 power. In fact, I'm going to leave this as square root of x squared plus 1 squared. Now I'm going to try to get rid of this denominator, so I'm going to multiply by the square root of x squared plus 1 over the square root of x squared plus 1 over 1. So that y prime would become what? Square root of x squared plus 1 times square root of x squared plus 1 is x squared plus 1 minus, these would cancel in the second case, and that's just an x squared plus 1. And I could just drop that 1 off. So now we have down below the square root of x squared plus 1 squared times this again is cubed. So up top, what do we have? These are going to go away. There's no plus 1 there. So we have 1 over the square root of x squared plus 1 cubed. Okay, let's find the derivative of f of v equals 1 minus 2v over 1 plus v quantity cubed. So f prime of v is going to be 3 times 1 minus 2v over 1 plus v to the 2 power times the derivative of what's inside. And then now we have the low, which is 1 plus v, d high, which is going to be negative 2, minus the high, which is 1 minus 2v, d low, which is just 1, all over 1 plus v squared. So our f prime of v is going to be 3 times 1 minus 2v over 1 plus v squared times negative 2 minus 2v minus 1 plus 2v over 1 plus v squared. Let's see where this is going to go. Looks like we have a minus 2v and a plus 2v. So we have negative 3 times, now check this out, this is a 1 minus 2v on top squared. Then we have 1 plus v squared down below, but we have another 1 plus v here. Negative 3 over 1 plus v squared. Negative 3, no, that's a positive 3, times negative 3, that's negative 9 times 1 minus 2v squared over 1 plus v to the 4th power. I apologize if my v's look like u's. Okay. I'm going to go ahead and scroll the page in a moment, so pause if you need to pause that. Now we're going to talk about trigonometric functions and the chain rule. And this really isn't too surprising. So we have the derivative with respect to x of sine x, just going to be cosine u times u prime. Derivative with respect to x of tangent u, I should say, not x, secant squared u times u prime. Derivative with respect to x of secant u is secant u tangent u, u prime. Derivative with respect to x of cosine u is negative of sine u, u prime. Derivative with respect to x of cotangent u is negative cosecant u, u prime. The derivative with respect to x of cosecant u is cosecant u cotangent u, u prime. So find the derivative of the trigonometric functions. So in this first one, our u would be pi x, meaning u prime is just pi. So y prime is going to be cosine of pi x times pi, which is pi cosine pi x. And this next one, our u would be the x plus 1, so u prime would be 1. So y prime would just be negative sine of x plus 1 times 1, or negative sine of x plus 1. In C, u is 3x, so u prime would be 3. Y prime would be, and what's our derivative of cotangent? Isn't that going to be cosecant? I think there's a negative there, isn't there? Cosecant, double check that. Yeah, it'd be cosecant negative. Negative cosecant squared of 3x times 3. So we're looking at negative 3 cosecant squared of 3x. For D, y equals 2 tangent 3x squared. Now, the squared only belongs to the x, not the 3, and definitely not the tangent. So our u is 3x squared, so our u prime is going to be 6x. So y prime is going to be 2 times secant squared of 3x squared. Secant squared is the derivative of the tangent, times our 6x. So y prime is going to be 12x times secant squared of 3x squared. And e, now tangent 3 is just a number. It's a constant. So y prime is going to be 2 times tangent of 3 times 2x. And that's going to be 4x, no, let's say 4 tangent of 3 times x. I need to scroll that up to finish this example. For f and g here. Okay, now our u is going to be 3x squared, which is 3x quantity squared, so that's 9x squared. So u prime is going to be 18x. Our y prime is going to be 2 times secant squared of 3x squared times 18x. So y prime is going to be 36x times secant squared of basically 9x squared. And this last one is going to be 2 tangent x. So u prime is going to be 2 times secant squared x. So think of this as we have u to the 1/2 power. So y prime is going to be 1/2 times this quantity, which is 2 tangent x to the negative 1/2 power times the derivative of what's inside, and that's going to be 2 secant squared x. So y prime is going to be secant squared x over the square root of 2 tangent x. Okay, I'm going to go on to the last page here. We have one more example to do. It says evaluate the derivative of the function at the indicated points. Okay, f of x equals 3 over x cubed minus 4. That's basically 3 times x cubed minus 4 to the negative 1, and the point is negative 1, negative 3/5. So if our u is the inside part, x cubed minus 4, our u prime is 3x squared. So f prime of x is going to be 3 times negative 1 times x cubed minus 4 to the negative 2 times this derivative, which is 3x squared. So f prime of x, negative 3 times 3 is negative 9x squared over x cubed minus 4 squared. F prime of negative 1, that's our x value, is going to be negative 9 times negative 1 squared over negative 1 cubed minus 4 squared. It's negative 9 over negative 1 minus 4, negative 9 over negative 5, or 9/5. Oh, that's a mistake. That should have been squared here. So that should be squared. And so the negative doesn't go on top. Negative 9 over 25. There we go. Okay, I hope you enjoyed that. Thank you. I enjoyed that. I think this is kind of fun stuff. And send me your questions. Thank you.